So question number 1. Identify the bottleneck for the current process and calculate the average weekly capacity in terms of number of units of final product produced per week. So as I have already discussed with you that capacity for a batch process is equal to available time divided by time per batch. And time per batch is equal to setup time plus run time. This is the formula that we will require for the processes that are having actually the changeover. So that will be equal to setup time or changeover time plus batch size into time per unit. So stamping process makes both part A and B, and there is a changeover time of 120 minutes whenever we are switching between part A to B or B to A. So I will not write the formula. So this is the capacity actually in number of batches. So that should be in your mind. So for stamping, the capacity will be equal to available time is 40 hours per week. So there are 5 working days and 8 working hours. And in minutes, that will be multiplied by 60. Now the setup time is 120 minutes whenever we are switching from A to B and 120 whenever we are switching from B to A. So that is the setup time. Now the batch size for part A is 360 and it requires 1 minute to make one part A. And we are making 720 part Bs and each part B requires half a minute to be made on the stamping machine. So that is the setup time and this is the run time. So batch size into time per unit. So that will turn out to be 2400 divided by this is 240 plus 720. So the capacity of stamping is 2.5 batches per week. And this is batches per week, capacity in batches per week. What is the capacity in boxes, window boxes per week? So that will be equal to the batch size into number of batches. So number of batches are 2.5 and the batch size is 360. So 2.5 into 360 will be 900. So 900 boxes per week. Similarly, for painting, capacity in batches per week will be equal to available time divided by time per batch. So available time is the same, 2400 minutes. So the capacity will be equal to 40 hours per week or 40 into 60 minutes per week. Now the changeover time is 20 minutes for painting. And of course, part A and B are painted the same color for a certain batch. So this is the changeover time of 20. Now each part A requires half minute to be painted and each part B requires 10 seconds. So 10 seconds is equal to 1 over 6 minutes. So that is 1 over 6. into 720. So that turns out to be 2400 divided by 20 plus 180 plus 120. So that is equal to 7.5 batches per week. And in terms of number of boxes per week, that will be equal to batch size into number of batches. So that will be equal to 7.5 into 360. So that is 2700 boxes per week. And finally, we have the assembly process. Now, assembly process does not have any changeover. It is not a batch process. It is a manual process. So the capacity will be equal to available time divided by time per unit. So available time is the same. Now, what is the time per unit? So it is given that 27 minutes are required to make one part, to assemble one part. So that will be equal to 2400 divided by 27. So that will be approximately equal to 89 parts per week. Now, these are the parts made by one worker, and there are 12 assembly workers. So this is for one worker, and there are 12 assembly workers. So capacity will be equal to 89 into 12. So that will be equal to approximately 1067 boxes per week. Now, out of these three, the stamping has a capacity of 900, painting has a capacity of 2700, and assembly has a capacity of 1067. So this is the process. Stamping has the lowest capacity, so this is the bottleneck, or this is the slowest process in this series of processes. And of course, in calculating the capacity, we are assuming 100% efficiency. And this is the result that we have achieved. Question number 2. What is the average utilization of the workers and the machines? And here we are assuming, in fact, it is given in the case study as well. We are assuming that the demand is of 800 boxes per week. Of course, in order to calculate utilization, you do need to have the information on the demand. So there is a formula actually of utilization. There are different formulas of the utilization. They actually conceptually mean the same thing. So one of the formulas that is applicable now is that the utilization is equal to flow rate over capacity. So the flow rate is what you are producing and capacity what you can produce. So utilization of stamping will be equal to, the flow rate is 800 divided by the capacity of 900. So that will be equal to 88.89%. Similarly, the utilization of painting will be equal to 800 divided by 2700. So flow rate is 800 and capacity of painting is 2700. So that is approximately 29 point something. So about 30%. And utilization of assembly is 800 divided by 1067. So that is 74 point something, so about 75%. Now, whenever you are having utilization less than 100%, that means that the demand is less than the capacity. So the demand is 800, but the capacity of the company is 800. So capacity of the company is 900. So demand is 800 and capacity of the organization is 900. So capacity is greater than the demand. So whenever this is the case, then utilization will be less than 100%, as you can see in this case. So we can produce more, but we are producing less because there is lesser demand. So capacity is 900 and demand is, we are assuming the demand to be 800. So such a system is called demand constraint system. So when demand is less and capacity is more. So output is depending upon the demand. If the opposite happens, and that is the case, actually this is the case for most of the make to order organization, but if opposite is the case, that is called the capacity constraint system. So output depends upon the capacity. We are producing whatever we can. So we are not producing more because we cannot produce more. So that is a capacity constraint system.